Solve problem on queuing model 9 by using important formulae. Let us understand some important formulae in queuing model 9 which is used to solve the machine repairing problem. It is symbolically represented as MMC GDMN. First symbol is M, that is Poisson or exponential arrival distribution. Second symbol is M, that is Poisson or exponential service time distribution. Number of servers provided, that is the multiple server, because here symbol C is there and C should be always greater than 1. Then GD. This model is used to solve the machine problems, and that's why the service discipline is general service discipline, that is GD. Number of machines allowed in the system, that is M. So this number is finite, and the total number of machine, or we can say population or calling source, that is also finite, and that is N. So we can say that out of total N number of machines, M number of machines are broken down and these M number of machines are allowed into the system. So M is the queuing capacity. Now we will move to the first formula. Probability of empty system, that is P0 is equal to summation of N is equal to 0 to C minus 1, where C is the number of servers, M factorial divided by N factorial M minus N factorial into lambda by mu raised to N plus summation of N is equal to C to M factorial divided by N factorial M minus N factorial into C factorial C raised to N minus 1 lambda by mu raised to N and whole bracket raised to minus 1. So we have to first solve this first part, then we have to solve this second part, then we have to add these two parts, and then we have to take this minus raised to minus 1, and then we will get the value P0. Now we will move to the next formula. So what is the probability of N number of machines in the system? So here there are two cases, that is N when N is less than C, because C is the number of servers. So when N is less than C, we have to use this formula M factorial divided by N factorial M minus N factorial lambda by mu raised to N into P0. Now what is the second case? So in second case N is greater than C. So we can say that C is less than or equal to N is less than or equal to M. So when C is equal to N, or we can say C is less than N, then we will use this formula. So N should also be less than or equal to M, because M is the total number of machines allowed into the system. So this N should always be less than or equal to M. So this is the formula Pn is equal to M factorial divided by M minus N factorial C factorial C raised to N minus C lambda by mu raised to N P0. Now we will move to the next, that is the number of machines waiting in queue, that is length of the queue LQ is equal to summation of N is equal to C plus 1 raised to M N minus C Pn. Then length of the system, that is the total number of machines in the system, Ls is equal to summation of N is equal to 0 to C minus 1 Npn plus summation of N is equal to C to M Npn. Then effective arrival rate, that is lambda E is equal to lambda M minus Ls. So this Ls we have to use here. So lambda E, effective arrival rate, we can use the second formula summation of N is equal to 0 to M lambda M minus N Pn. Then waiting time in queue, that is equal to LQ by lambda E, and waiting time or waiting time plus time to take the service, that is total time in the system, that is Ws is equal to Wq plus 1 by mu, because Wq is waiting time in queue and 1 by mu, that is total service time that we have to consider. So Wq plus 1 by mu, or we can use the other formula, that is equal to Ls by lambda E. So you have to note down all these formulas which are useful to solve the problems. Given question is, there are 5 machines, each of which, when running, suffer breakdown at an average rate of 2 per hour. There are 2 servicemen and only one man can work on one machine at a time. If n machines are out of order when n is greater than 2, then n minus 2 of them have to wait until serviceman is free. Once a serviceman starts work on machine, the time to complete repair has exponential distribution with mean of 5 minutes. First question, find the distribution of number of machine out of action for a given time. Second, find average time an out of action machine that has to spend waiting for repairs to start and being repaired. Let us understand the given data. Number of machines which are running and suffer breakdown is given, and that is equal to 5. So we can say that the number of machines allowed into the system, that is M, is equal to 5 machines. Then the service time is mentioned 5 minutes and the arrival rate lambda is 2 per hour. So we have to convert this time that is given in minute into hour, that is 5 by 60 hour. So how to calculate service rate? So service rate mu is equal to 1 divided by service time, that is 1 divided by 5 by 60, which is equal to 12 per hour. Then number of repairments is also mentioned, that is C is equal to 2. There is one condition is given, that is if number of machines broken down that is equal to n, then this n is greater than 2. So this condition is mentioned, that is the number of machines broken down and that are in system that is always greater than 2. Then the number of machines waiting is equal to n minus 2. Now we will move to the first question. First question is that probability of n machines in the system at any time t. So we have to find out here Pn, that is the probability of n machine of the system in the system. So for this n, condition is given that n is greater than C, because C is equal to 2. So we can put here the one condition that n number of machines that are broken down and allowed into the system is greater than this C, but it is less than 5 because Q capacity is 5 machines. So we can write here, while find out the Pn. Now for this n we will write here the condition, that is C is less than n and n is less than or equal to m. So this is the condition for which we have to write the formula for Pn, because C is less than n, because here the condition is mentioned n is greater than 2 and 2 is equal to C. So for this condition we have to write the formula for Pn and we have to find out the probability of n number of machines in the system. Now we have lambda value as well as mu value. So what is the ratio of lambda by mu? So which is equal to 2 by 12, which is equal to 1 by 6. So we will refer this value 1 by 6. Now first we will calculate P0, that is the probability of empty system, because this P0 is required to calculate Pn. Now here is the formula. Summation of n is equal to 0 to C minus 1. So I will write the formula at the same time, that is summation of n is equal to 0 to C minus 1, that is 2 minus 1, 1, m factorial, that is 5 factorial, divided by n factorial. So n factorial, that is unknown, so I will write here n factorial, m minus n, that is 5 minus n factorial, lambda by mu, that is 1 by 6 raised to n. So this is the first part. So I will make here the curly bracket, plus second part is that summation of n is equal to C. So C is 2 up to m, that is 5. M factorial, that is 5 factorial, divided by n factorial, 5 minus n factorial, C factorial, C raised to, that is 2 raised to n minus 1, 1 by 6 raised to n. So this curly bracket complete because this is the second part and raised to -1. Now we will solve this. So here is the summation. So we have to first put n is equal to 0. So when we put n is equal to 0, then 5 factorial divided by 0 factorial into 5 minus 0, that is 5 factorial, and 1 by 6 raised to 0, that is anything raised to 0, that is 1, plus. Now we will put n is equal to 1. So 5 factorial divided by 1 factorial, 5 minus 1, that is 4 factorial, and 1 by 6 raised to n, that is 1 by 6, that is 1 by 6 raised to 1, that is 1 by 6. So this is the first part. Now we will move to the second part. Now here we have to put n is equal to 2. So n is equal to 2, that is 5 factorial divided by 2 factorial, 5 minus 2, that is 3 factorial into 2 factorial, 2 raised to n minus 1, that is 2 minus 1, that is 1, and 1 by 6 raised to 2, that is square, plus. Now we have to put n is equal to 3, 4 and 5 because we have to take this range from 2 to 5. So again we will take 5 factorial divided by, here is 3 factorial, 2 factorial, 2 factorial, 2 raised to 3 minus 1, that is 2, 1 by 6 raised to 3. Now we will put 4. So I will write here 5 factorial divided by n, that is 4 factorial, 5 minus 4, that is 1 factorial, 2 factorial, and 2 raised to 4 minus 1, that is 3, 1 by 6 raised to 4, plus. Now we will put n is equal to 5. So 5 factorial divided by 5 factorial, 5 minus 5, that is 0 factorial, 2 factorial, 2 raised to 5 minus 1, 4, 1 by 6 raised to 5. So this curly bracket will also complete, and then we have to take raised to -1. Now here I will put the square bracket. Now how to simplify this? So we have to solve this first part and then solve to second part. So if we observe here 5 factorial is getting cancelled. Now here 5 factorial, that means 5 multiplied by 4 factorial. So here also 4 factorial is getting cancelled. So in the same way we have to cancel this. So here also 5 multiplied by 4 multiplied by 3 factorial. So this 3 factorial is also getting cancelled. So we have to cancel this and we have to solve these brackets. P0 is equal to, first part solution is 0.834 plus, now in second part 0.277 plus 0.092 plus 0.0154 plus 0.00102 bracket, whole bracket raised to -1. So when we solve this, 2.21 raised to -1, which is equal to 0.45. So value of P0 we have to take 0.45. Now we will move to calculate Pn. So probability of n number of machine in the system where the condition for n is given, C is less than n, and this n is less than or equal to m. That is the range of n we have to take, that is from 3 to 5. So we have to take n is equal to 3, 4, 5. And what is the formula? That is m factorial divided by c factorial m minus n factorial c raised to n minus c into lambda by mu raised to n into P0. Now when we take n is equal to 3, then how we can write this formula? P3 is equal to m factorial, that is 5 factorial divided by c factorial, that is 2 factorial, m minus n, that is 5 minus 3, 2 factorial, c raised to n minus c, that is 2 raised to 3 minus 2, that is 2 raised to 1, into 1 by 6 raised to 3 P0. So when we solve this, we will get 0.06944 P0. Now in the same way we have to write the formula for P4. So instead of n, here put 4, and we will write here 5 factorial divided by 2 factorial into 1 factorial, 2 square, 1 by 6 raised to 4 into P0. Answer is 0.01157 P0. Then P5 is equal to 5 factorial divided by 2 factorial into 3 factorial, 2 cube, 1 by 6 raised to 5 P0. Answer is 0.00096 P0. So how to calculate Pn? That is, we have to add this P3, P4 and P5. P0 is common term, so we will take outside the bracket. So when we add all these values and multiply with 0.45, then we will get the answer 0.036. Now we will move to the next question. We have to find out the waiting time in queue as well as time spent in the system, that is WQ and WS. So for that calculation, we have to first find out length of the queue as well as length of the system. So how to find out length of queue? That is LQ is equal to summation of n is equal to C plus 1 to m n minus C Pn. Now if we put here n is equal to 2 plus 1, because C is equal to 2, that is n is equal to 3 to 5 n minus C Pn. Now we will put the 1 by 1 value, that is the range of n is from 3 to 5, that is 3, 4, 5. So when we put n is equal to 3, then here it will become 3 minus C, that is 3 minus 2, 1. Pn, that is P3, plus, now we will put 4, that is 4 minus 2, that is 2. Then here P4 plus, now n is equal to 5, that is 5 minus 2, that is 3. Pn, that is P5. Now P3, P4 and P5 we have calculated earlier. So in terms of P0 we will write the value, and outside the bracket we will take this P0. So 1 into 0.0694 plus 2 into 0.011 plus 3 into 0.000964, and P4 as P0 as a common term, so we will take outside the bracket. So when we solve this, now P0 value we have to take 0.45. So when we solve this, we will get 0.042. So this is the length of the queue, that is 0.042 machines in the queue. Now we will calculate length of the system. Here is the formula, summation of n is equal to 0 to C minus 1 npn plus summation of n is equal to C to m npn. Now we will put the value. Summation of n is equal to 0 to 2 minus 1, that is 1, npn plus summation of n is equal to C to m, that is n is equal to 2 to 5 npn. Now if we observe here, we have to take 0, that is 0 P0 plus 1 P1. So P0 that we have already calculated, and value of P1. So we have to calculate here P1. So what is the probability when one number of machine is there? But if we compare this n and C, then n is less than C. So to calculate Pn, we have to use the formula for this condition, n is less than C. So here is the formula, m factorial divided by n factorial m minus n factorial lambda by mu raised to n P0. So when we put the value, because P0 is 0.45, so I will write here n is equal to 1. So here P0 that already we have calculated, now we will calculate P1. So P1 is equal to 5 factorial divided by 1 factorial, 5 minus 1, that is 4 factorial, lambda by mu, that is 1 by 6 raised to 1 P0. Now we will write this term, we will write the answer in terms of P0. So here 5 by 6, that is 0.83 P0. Now P3, P4 and P5 we have already calculated. Now we have to calculate P2. So when n is equal to 2, we have to write here for the second term 2P2 plus 3P3 plus 4P4 plus 5P5. So this P3, P4, P5 we have already calculated in terms of P0. Now we will calculate P2. So if we compare this value, n is equal to 2 and C is also equal to 2. So here is the condition that n is equal to C. So we have to use the formula for when n is less than or equal to C. So here, n is greater than or equal to C. So this is the formula, n is greater, because this is the formula only for n is less than C, and here is the formula for n is greater than or equal to C. That is when n is equal to 2, when n is equal to 3, when n is equal to 4 or n is equal to 5, because all these to calculate P3, P4, P5 same formula is used. So to calculate P2 also we have to take the same formula as for used for P3, P4 and P5. So m factorial divided by m minus n factorial, c raised to n minus c, lambda by mu raised to n, P0. Now we will put the value. 5 factorial. Now here 5 minus 2, that is 3 factorial into 2 factorial, 2 raised to 0. So anything raised to 0 is 1. And 1 by 6 raised to 2, P0. So when we solve this, we will get the answer 0.27 P0. Now we will take the other values also. So what is 0 P0? That is 0 into 0.45. That is 0 plus 1 P1. That is 1 into 0.83 P0. Now we will take P0 outside the bracket because it is the common term. Plus 2 P2. That is 2 into 0.27 P0. That is 2 into 0.27. So I will put here curly bracket plus 3 into 0.0694. P0 we will take outside the bracket plus 4 into P4, that is 4 into 0.011 plus 5 P5, that is 5 into 0.000964, and outside the bracket P0, that is 0.45. So when we solve this we will get the answer 0.732 machines. So here unit will be machines because these number of machines are in the system. Now we will calculate effective arrival rate, that is lambda E, which is equal to lambda m minus ls. So this lambda is given in our 2 into m, that is 5 minus 0.732, which is equal to 8.536. Now we will calculate W2, that is waiting time in Q, which is equal to LQ by lambda E. So LQ is 0.042 divided by 8.536, which is equal to 0.0049, and unit is hour because this lambda is given in hour, which is equal to, if we convert this into minute by multiplying with 60, 0.29 minute. Then we will calculate waiting time in the system, that is WS, which is equal to LS by lambda E, which is equal to 0.732 divided by 8.536, which is equal to 0.085 hour, which is equal to 5.14 minutes.